right. I'm going to be speaking on the topic, simple is better than complex. And a little bit about my info. I'm a web developer with Python and Django, currently an NYSC intern at LS Scientific Limited here in Lagos, and a remote software developer at LBYL Limited, and a graduate of physics at Delta State University. Now, the aim of this talk. Why are we advocating for simple codes? Everybody knows that Python is the easiest language to learn. But somewhere along the line, we get this mixed up. When you see a Python code written, it looks like C++ because we tend to complicate things. And this is mostly done by those coming from other language. As I already, the talk aims to bring us back to Python's original philosophy of being easy to read and easy to write. Now, the title of this talk is drawn from line 3 of the Zen of Python, which says simple is better than complex. In case you are totally new to Python, you can just type import this on idle, and you get a copy of it. Now, who is this talk targeted at? It's targeted at beginners. You are very new to Python, you don't know much, or perhaps you are intermediates or non-core developers, meaning you are coming from another language. You don't really understand Python's philosophy very well. Now, importance of code simplicity. According to Abelson et al., it said program must be written for people to read and only incidentally for machines to execute. The only reason we have programming language in the first place is so we can see what we are doing. So you can interact with the code you are writing. If not, we should be coding in binary. So if you write code, especially in Python, and it's not readable, then you are defeating the philosophy of Python. Also, it makes teamwork easier. The keynote speaker just now was talking about remote work, and most of the times when you're working remotely, you're collaborating with a team. Now, when your colleagues have to ask you up all the time, hey, what's this line of code doing, what's this block of code doing, then it doesn't speak good of you, you're not a good developer. Then it makes debugging easier. Thank you. It makes debugging easier. When your codes are simple enough, it's very easy to spot bugs in your program. I have been a victim of this once. Sometime I wrote a program, I think a web scrapper or so. Then when I was learning, they said, comment your code so you know what each part is doing, because if you come back to it later on, you might not understand what you wrote. I thought, come on, I wrote it, I can easily understand. Not until 3 days' time, this was just, less than 3 days' time, I needed to change a portion of the code. Ladies and gentlemen, I couldn't figure out what my own code was doing. Then I was just coding anyhow, function, calling a function inside a function, everything messed up. And just to change one line of code, it was difficult. I nearly had to start rewriting solving the problem from scratch to figure out, okay, this is what this part is doing, and this is what this part is doing, before I could actually understand it, and that's not a very great thing. So writing codes in a simple manner makes debugging very easy for you. And finally, some idioms can be faster and use less memory. Python idiom has specific Python syntax that makes you achieve more with less lines of code. And these idioms have been specially developed to perform certain tasks, to solve certain problems in a very efficient manner. So you won't have issues using them at all. Now, before writing any code, before solving any problem, you have some checklists. First of all, you check the standard library. There's a high possibility that the problem you want to solve is already part of the standard library. So you check if the standard library already contains a method or a function for what you want to achieve. There's no point. Where this complexity comes in is you're trying to reinvent the wheel. A problem that has already been solved in an efficient manner, you're trying to do it in your own way. Now, this is very good for learning purpose, but if you're in a production environment, there's no need to do that. There's no need to prove your competence. If what you want to solve is already in the standard library, then it's best to make use of it. It makes things simpler. Also, even if it's not in the Python standard library, you can check the Python package index. That's a collection of all Python modules for, in fact, anything you can think of. You're most likely to find a package on it on Python package index. Also, check for existing solutions by seasoned programmers. The truth is that people have been there before us. They've solved most of this problem. There's no harm in Googling. It doesn't make you less of a programmer. I Google my codes all the time. I want to solve this. Okay, how to do this? Check for what other people have done. No matter how smart you are, you cannot be smarter than a community. Go to your community for help. Check the solutions your community has provided for that problem. So now let's start seeing some of these complications in our code. First, I will start from the basics so everybody can follow along. So even if you just started learning Python yesterday, you can flow with us. The first is assigning multiple variables. I want to assign 3 variables at a stretch. I have A equal to 1, B equal to 2, C equal to 3. Normally, in other languages, I can do it 3 different lines. But in Python, the more Pythonic way is doing it on a single line of code. As you can see on the other side of the slide, A, B, C is equal to 1, 2, 3. Straightforward. You have assigned 3 values to 3 variables. Also, you have a list containing 3 items. And you want to unpack those items into 3 variables. Normally, what some people do, my list, you use the index to get the item out. A is equal to my list 0, B my list 1, C my list 2. That's how some people manually unpack a list or a tuple. A more Pythonic way to do that is my list. A more Pythonic way to do that is my list equals to A, B, or C. Assign the 3 variables A, B, or C is equal to my list. And one check for that is that you must make sure that the number of variables you assigned equals to the number of items in that list. Otherwise, you get an error. And also, you want to assign 3 variables to the same object. In Python, you can easily do that in one line. A is equal to B is equal to C is equal to whatever your variable is. Now, those 3 variable names points to the same object. Are we following? The next thing we're going to look at is Python's ternary style operator. Now, if you know JavaScript, you know of something called the ternary operator, an if-else statement on one line. So I want to assign a value to a variable if a condition is true. Normally, what you do is if some Boolean, assign this value is equal to 1. Else, let the value be 0. Print the value. Of course, we'll get 1. It works that way. But something simpler is value is equal to 1 if Boolean, else 0. Straightforward, right? Do we get that? OK. Now, moving forward, Python's variables are not boxes here. Now, when you are learning Python, probably in a bit to make you understand the concept, your tutor or probably the book you use told you that variables are like boxes where you put in value and use them wherever you want. This is true, except that it's not totally true all the time. In Python, variables are more like labels on these objects. What this implies is that a box can have more than one label, or better still, more than one tag. An example, a proof of this is I have A is a list containing 1, 2, and 3. And I assign B to be A. You understand that? Then I do B.append 4. I'm appending 4 to B. Now, if you print A, you realize that you are still dealing with the same object. That means assigning B to A doesn't duplicate the object. Instead, it creates a reference to it. You will get that. Are we following? In a programming language like C, what this does is that it creates a duplicate, creates another object. But in Python, it's not like that. You're actually dealing with the same object. Now, a direct implication of that is how we use the equality check. Now, most people actually see the is keyword in Python as a replacement to the equality operator. This is very wrong. Python's is keyword doesn't check for equality. It checks for singularity if 2 variables are pointing to the same object. Now, as an example, we have A is hello world, B hello world as well. Now, if you do A is B to give you false, because we just created 2 different objects. Do we get it? Do we get that? But if we do A is equal to B, we get true, because of course, A is equal to B. They are the same string. Now, we assign one of the strings, say A, which is hello world, to be equal to B. we assign C to be equal to B rather, and you do C is B, you get true because those two variables are pointing to the same object. Are we clear on that? Okay. Next is conditionals. Now, you want to perform an action if something is true. Let's take a list, for instance. You want to check if a list contains at least an object. Of course, common sense, you have the length function, very easy to do. You check if the length is greater than 0, means it contains an object, then you do your stuff. Or you have a number, you check if the number is greater than 1, you do whatever you want to do. Now, that works, but a more Pythonic way to do that is if a list, you don't have to use your length check or your greater than or whatever. Python automatically evaluates it to true or false, depending on the value you are using. Also, you can do if number. If the number is not 0, it evaluates to true. If it's 0, it evaluates to false. So you don't really need to check the greater than or less than. Now, as I checking for truth in this manner clearly shows the code intention rather than drawing attention to the outcome of the condition. Someone going through your code will not be distracted from what the code actually does. If you are doing your length, if length of a list is equal to 0, the person momentarily will be distracted to what the outcome of this condition will be. And that diverts attention from what is actually going on in your code. The following statements in Python evaluates to true. True, of course, evaluates to true. Any number other than 0 evaluates to true. A non-empty string evaluates to true. Non-empty collection. Collection, we have lists, tuples, dictionaries. So long they are not empty, they will evaluate to true. So when you want to use them in your code, you don't have to use an if condition. Except, of course, you actually want to do something other than if it contains an item. Say, for instance, you want to check if the number of items is more than 5, then, of course, it's very okay to use your if condition there. The next is multi-line strings. Strings are something we always use in our programs. And when they span a huge length of line, they tend to mess up our scripts. You know, horizontal scrolling in your development environment, in your test editor, having a horizontal scroll on your code is not it's not always a good thing. So it's better you break your long length of strings down. So example I have, this is a very long string, has been broken down into multiple lines. You can break them down into different lines rather than having them on a single line. Of course, with quotes. This is a very long string. The first line has been broken down on the second line into multiple lines on the third line. Now, when you print my string in this format, you see that Python automatically concatenates them for you. Now, we gain the concatenation function, and we get the code reliability at the same time. Now, we have string formatting. You want to join some strings with some variables. The normal way, of course, is to use plus. We want to write a function that returns a user info. You can do return name plus the username plus age plus the user age. That's very okay, but the more Pythonic way to do that is define username, you return name. Python's string formatting works in a template-styled manner. You have your variable in a curly bracket. You have the user.name there, then age, user.age. Then at the end of the string, you use dot format and pass the user variable to it, of course. User is equal to user. Let's move on. Building strings from substrings. We have a list containing strings and want to merge everything in the list into a string. Normal way to do that is, of course, you initialize an empty string, then you do for s in colors, add appendix to your results. That works, except that it uses a lot of memory. Excessive memory usage slows down your Python programs. A more Pythonic way to do that is using the join method. So you have your result is equals to empty string dot join. You have your colors. Are we clear with that? All right. Now we use return to evaluate simple expressions. You have a very simple function. You just want to return a value. There's no point assigning the value to a variable first. You are wasting variables, I would say. So add numbers, we want to write a function that adds two numbers. We have num1 and num2. We want to return the result of the addition of both. There's no point assigning them to results and returning the results. You can just go straight to add numbers, return num1 plus num2. It's actually cleaner that way. Now, looping with indices. You want to loop through a list, and at the same time, you want to make use of the position At the same time, you want to make use of the index of the objects you are looping. A normal way to do this is you make use of the length of the list. For I in range, the name of our list is colors. For I in range, the length of colors, print I, which is the position of the objects, then plus colors, which is the actual objects we are dealing with. If you run that, you get 0 red, 1 blue, 2 green, 3 black, 4 orange, 5 yellow. Now, that works, except that it's not totally readable, and we're actually doing more work, something that Python has already solved for us. Now, a more Pythonic way to do that is to use the enumerates function. Now, what the enumerates function does is it takes your iterable, regroups it into a tuple with its index. So a more Pythonic way to achieve this is for I and color is returning a tuple. You unpack it into two variables, I and color. The I is the index, the color is the actual object in the list. For I, color in enumerate colors. Enumerate is what does the whole job for us. Print the I and the colors. Of course, we get the same result. Which is simpler to read? Which is simpler to use? Of course. Now, something similar to that is we have two collections we want to loop over. We have colors and names, probably names of people and their favorite colors. The normal way to do this is we make use of the minimum, the list with the minimum length. So we do n is equals to minimum length of names and length of colors. Check the minimum between both, then do for I in range of the minimum number, print names and colors. That works, but what works better is the zip function. Python zips takes two lists or two collections, better put, and groups them into a tuple each. The first two items from each list becomes a tuple. The second one, like that, and you can print it, name plus color, you get the same value. Now the next is list comprehension. Now this is one of the most juicy parts of Python. If you're not using list comprehension, trust me, you are cheating on yourself. Now, most of the time, what's the data type we work most with when programming, you agree with me, is list. And that means most of the times you want to loop over the items in your list. A simple way to do this is to use the normal for loop for item in a list. If the item meets this condition, append the item to the new list. Now, with list comprehension, what we'll do is the function you want to perform on the item, for item in a list, if the item meets the condition, a simple straight line statement. A direct example of that is that I want to square all numbers from 1 to 10. Using list comprehension, we use n raised to the power 2 for n in range 10. Range 10 returns the list. N raised to the power 2 squares all the items in the list. Very straightforward. That's list comprehensions for you. Now, when to use list comprehension? If you want to manipulate a list, you want to create another list from a list, you make use of list comprehension, of course. Now, if the list is just an intermediate step, you don't actually want to make direct use of the list generated, you are better off using a generator. And that's done by replacing the square bracket with a normal bracket. Now, when you finally get hold of list comprehension, trust me, it's something very interesting. You'll be tempted to use it most of the time. And that's not always a good thing. Now, You should not, because you can do everything with list comprehension, doesn't mean you should actually do everything with it. You shouldn't use a list comprehension when the condition becomes too complex, because you can perform the function on the item if the item meets a certain condition. But if this condition becomes complex, then list comprehension loses its readability there. Or we have deeply nested objects are involved, a list inside a list like that. List comprehension becomes unreadable here. Or if you don't actually want a list, then you don't need a list comprehension. An example, I want to set location to home for all teams in the home teams. I don't actually need a list, but I just want to perform all the items. I want to perform an action on all items in a list. A wrong way to do that is to use a list comprehension. That's not what list comprehensions are made. List comprehensions are made to generate lists from a list. A better way to do that is to use the traditional for loop method. Next is leverage on the power of sets. Most of the time you are working with sets, you find out that you want to check the difference between two lists or similarity between them or whatever. There's no point writing your own function. That's what sets exactly are meant to handle. You just need to have a basic understanding of mathematical sets theory. If A and B are two sets, the difference between these two sets are the elements in A but not B. I don't have to explain all that. It's basic mathematics. But check out how to use sets. It will help you a lot. Example of set in operation, I have two lists. The first one is range 5 and range 10. Of course, you know what this does. The first one generates a list of numbers from 1 to 5, the other one from 1 to 10. Now, I want to check the items that are common to these two lists. Normal way to do it is you initialize a list name common, then you look through for elements in list 1. If the element is not in list 2, if element is in list 2, you append it to the common list. Finally, you print your common list. That works. 0, 1, 2, 3, 4. We get our result. But a more Pythonic way to do this is to use the sets. First of all, you convert the list to sets to be able to make use of the set methods. So you convert list 1 and list 2 to sets, and use the AND to find the items that are similar in both of them. And when you print your common result, you find out that you have the same thing. So you can see that set is actually easier to use than writing custom functions for your list. Next, we're going to check EAFP versus LBYL. These are acronyms for easier to ask for forgiveness than permission versus look before you leap. It is easy. When coding in Python, most of the time you want to check if something exists, do something. A better approach, Python's philosophy is easier to ask for forgiveness than permission. Try what you want to do. If it fails, then handle the error. Example, if your variable x must be a string for your code to work, it's better to call string. Better to call your string function on the x, then if it fails, catch the exception, rather than checking if x is actually a string first, because that will slow down your code. Time of checking the condition versus time of actually performing your computation. Now, an example of that is we want to count the items in a list. A simple way to do that is using a dictionary. You check if the item already exists, append to the dictionary, otherwise initialize it and set it to 1. A better way to do that is using the dictionary get method. What it does is, first of all, it tries to add 1 to the item. If it doesn't exist, it uses 0 for it and actually adds 1, which actually follows the EAFP method, easier to ask for forgiveness than permission. Okay, I think our time is up. Lastly, we'll look at use decorators to factor out business logic from administrative logic. Decorators are one of the most underused Python philosophy that I think we have. Example, we have a function that collects a page from the internet, and at the same time, we don't want the page to be collected twice. If it has already been collected, use the cached result. Easy way to do that is you have a dictionary, you name saved. If the URL is already in saved, return the URL. Otherwise, get the URL with request. An easier way to do that, I don't want to go through the stress of showing you how decorators work, but they are pretty easy. Use the decorator at cage. Now, at cage handles the caching. Why? Before you define your main function, web lookup, return the URL. At cage checks if it already exists. If it already exists, then there's no need for our function to run. It uses the cage result. Otherwise, it gets the website afresh. Now, other notes which I couldn't put into the slide because of time, clarify function call with keyword arguments. Use keyword arguments for your functions. It makes it clearer what you are trying to achieve. Return named tuples for multiple outputs. Good naming is essential. It makes what your work is doing clearer. Use backslash to continue statements. I told us earlier how having horizontal scroll on your text editor is not a very good thing. Now, catch specific error in a try except block. Don't always bar an exception. You have a try except statement in your code. Don't use if except exception. Don't use pass in that exception. Catch the particular exception you are looking for. Example, if value error, do this. If you do if except exception and you use pass to handle it, most of the time it leads to undesirable effects. You might have other bugs in the code that you have no idea of, and it's just silenced. You won't know about it. Avoid wildcard imports. It messes up your namespace. Use the particular module you want to import from this, import this, and this. It's better that way. It makes it clearer where what is coming from. Avoid the use of one-time variables. If you will need your variables just once, you don't have to initialize a variable for it. You can just make use of your value directly. And finally, use underscore for throwaway variables. There are sometimes you actually need a variable that you don't need. For example, you want to unpack a tuple that has 2 items in it. Using one variable will give you a syntax error. You just need another variable just to make it syntactically correct. You can just use underscore to denote that this variable is not needed for anything. Finally, ladies and gentlemen, thank you very much.